Okay, guys. So this is going to be trig review. All right, you're going to have a sort of like an assessment, if you will. It's not a test or quiz. It's just to see if you really understand what it is that we are trying to accomplish here in this unit. Okay. So basically, what I want you guys to try to take from this unit is just I want you to try to familiarize a little bit with this unit circle here. Okay, because that'll help you as you take Algebra 2 and as you go into calculus. Okay, it's important to try to memorize these values here, right, for these specific angles. Okay, if you notice, they're very specific. Okay, we're not trying to memorize the sine and cosine values of like 32 degrees. Okay, these are ones that you're going to want to try to have to memorize as you go in the future. Okay, we'll get to that part in just a second here, but I want to get to what we've been going through, which is talking about, which is these trigonometric ratios, okay, which allow us to find whether it be a side or a missing angle for right triangles, okay. So this beginning part here is just to kind of give you some more notes on that kind of stuff in case you're still kind of fuzzy with it. So, here's it kind of talks about SOHCAHTOA, what sine means, opposite over hypotenuse, cosine, adjacent over hypotenuse, or adjacent over hypotenuse, tangent, opposite over adjacent, okay, stuff involving right triangles, all right, just kind of showing a little bit of what these things, where these things are coming from, and then again, SOHCAHTOA there, okay. So, we're going to just go right into the homework section, okay, and so I'm going to do all of the even ones. So your homework is going to be to do all of the odd ones. Okay? And then I'm going to do these ones down here as well. Okay, so you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 problems for homework. Okay? So, let's get started here. So, find the missing side. Alright. I can shrink this in there so I can get all three at once. So, SOHCAHTOA. SOHCAHTOA. Okay. So, in this first one here, alright? Now, in all of these cases, we're finding the missing side. Alright, so they give us the angle, and it's up to us to use those ratios to find the missing side. Okay, so this one is our adjacent side. This is our hypotenuse. Okay, so which one involves adjacent and hypotenuse? Well, that's cosine. So we're going to go to cosine. 73 degrees is equal to x over 6. Multiply both sides by 6. And you get x is equal to 6 times the cosine of 73. Zoom in here so you guys can see better. Right? So the cosine of 73 times 6. You get x is equal to, and this is what round to the nearest tenth, so 1.7, or I'm sorry, 1.8. Okay, so that's your answer for that one. Let's go down here. So again, SOHCAHTOA. I'm just going to write it for all of them. SOHCAHTOA. Save myself some time. Okay, let's go back up. All right, so this one, they give us our adjacent side, and we need to find our opposite side. So which one involves opposite and adjacent? Well, that's tan. So the tan of 37 degrees is equal to x divided by 12. All right, and so we're going to go multiply by 12. So you get x is equal to the tan of 37. So the tan of 37 times 12, and you get 9. It says round to the nearest tenth, so it's just going to be 9. Because you're going to get 9.09. 0.04, which 4 doesn't round anything up, so your answer is just 9. Okay, now again, make sure you're in degree mode. Okay, if you're not, you're going to get some wrong answers. So what you want to do is you want to go to mode, and then go down and select degree. Make sure degree is highlighted and it's beeping. Okay, that's what you want. And so this one right here. All right, this is our hypotenuse. This is our opposite side. All right, so which one involves opposite and the hypotenuse? Well, that's or sine. So the sine of 51 is equal to 14 divided by x. Multiply both sides by x. Then we're going to end up dividing by the sine of 51. So x is equal to 14 divided by the sine of 51 degrees. All right. Hopefully I'm not going too fast there. I hope you guys are recognizing that to get, maybe I should just jump back here a second. All right, so you have, just so you guys are seeing the process, x times the sine of 51 degrees is equal to 14. So you divide by sine of 51, divide by sine of 51, and that's where I'm getting this answer. X is equal to 14 divided by the sine of 51. All right, so 14 divided by the sine of 51, and rounded to the nearest tenth, you're going to get 18.01, which is about 18. Okay, let's keep going. Number 8. Okay, this one, they give us the sides, and we're missing the angle. All right, so this is our, remember this is our hypotenuse, so this is our adjacent side, this is our opposite side. So the one that involves opposite and adjacent is tan. So the tan of theta is equal to 3/3, which is just 1. So we're going to take the inverse tan of both sides. By doing so, tans cancel on the left, and you get the inverse tan of 3/3, which is just 1. So the inverse tan of 1 is 45 degrees. And we'll get into that part later, all right? But 45 degrees is special, all right, because it has, so if the sine of 45 degrees is equal to square root 2/2, and the cosine of 45 degrees is equal to square root 2/2. And that comes directly from our unit circle. Okay, what happens is tan of theta is equal to the sine of theta divided by the cosine of theta. And then so what happens is you get square root 2/2 divided by square root 2/2, which just becomes 1. Right, and so that's where these things are coming from. So the tan of 1 degree, or I'm sorry, 45 degrees is just 1. And I'll explain that a little further once I get back to the unit circle part. Okay? So this one here. So find the indicated side. Okay? So this is our opposite side. This is our adjacent side. So we're going to get, let me write TOA. All right, so which one involves opposite and adjacent? Well, that's tan. So the tan 32 is equal to x divided by 13. Multiply both sides by 13. So x is equal to tan of 32 times 13. Whoops. Tan of 32 times 13. Run it to the nearest tenth, 8.1. Okay. The next one. So, 60 degrees here. All right, this is our hypotenuse, remember, because it's directly across from our right angle. This is our adjacent side. So SOHCAHTOA, which one involves our adjacent and our hypotenuse. Well, that's cosine. So cosine of 60 degrees is equal to x over 11. Multiply both sides by 11. Those cancel there. So x is equal to the cosine of 60 times 11, which is an even 5.5. Nice number there. Okay, Number 14. Write it in here. So, ka, toa. All right. They want us to find our hypotenuse. Okay, so this is our adjacent side. Or I'm sorry, whoa, brain fart. This is our adjacent side. This is our opposite side. Sorry. All right, so tangent involves opposite and adjacent. So we're going to go the tan 45 is equal to 35 divided by x. Multiply both sides by x. They cancel there. So you get x times the tan of 45 is equal to 35. Divide by the tan of 45. And you get x is equal to, so 35 divided by the tan of 45. Huh, what do you know? You get 35. Okay, and that'll play in, we'll play in a little more on the unit circle there as well, but 35 divided by the tan of 45 is just 35, because remember the tan of 45, if we go back up here, tan of 45 degrees is just 1, so which makes sense. 35 divided by 1 is going to be 35. Okay? Alright, let's keep going. 16. Alright, so this is our this is our hypotenuse. This is our adjacent side. And this is our opposite side. Okay, so katoa. Okay, which one involves our adjacent and our hypotenuse? That's cosine. So the cosine of 59 is equal to 34 divided by x. Multiply both sides by x. Let's cancel. And so x is equal to 34. Whoops. Whoops. Come on. What in the world? Oh, brother. This thing sometimes is just a pain in the butt. Okay. Give me the eraser. Thank you. Huh. Interesting. Alright. So x is equal to 34 divided by the cosine of 59. And so that is equal to, so 34 divided by the cosine of 59. And you get 66, and you want to round it to the nearest tenth. So 66.01, which is just 66. Okay, number 18. All right, they want us to find all of the sides. It says solve each triangle, so which means we need to find all three, or the other two sides for these triangles here. So this is our hypotenuse. This is our adjacent. Okay, so I'm going to set up a couple trig functions here. So ka, toa. All right, so in order to find our hypotenuse, all right, we're going to use our opposite. So sine involves opposite and hypotenuse. So the sine of 51 is equal to 9 divided by x. All right, so multiply both sides by x. Just cancel there, and to get x by itself, we need to divide by the sine of 51. So x is equal to 9 divided by the sine of 51. So 9 divided by the sine of 51. And you get, it says round to the nearest tenth, so 11.6. So this right here is 11.6. Okay, now we just need to find our adjacent side. So opposite and adjacent involves, or those are involved in our tan function. So the tan of 51 is equal to 9 divided by x. So again, we're going to go through the process. So x is equal to 9 divided by the tan of 51. And so this time you get 9 divided by the tan of 51. round it to the nearest tenth, 7.3. Okay, so that's our first one. Our second one, let me write this back in here again. So toa. All right, so this is our hypotenuse. This is our opposite. This is our adjacent. And so the first one, I'm going to find my opposite side. So sine involves opposite and hypotenuse. So the sine, let me zoom in here too so I can get this. 53 is equal to x divided by 5. So you multiply both sides by 5. And you get x is equal to the sine of 53 times 5. And it says round it to the nearest tenth, so you get 3.993. If we round that up, it's going to be 4. Okay, so the last one we need to find, all right, is the adjacent side. So let me mark this in here. It's going to be 4. So our adjacent and hypotenuse, that involves cosine. So the cosine of 53 is equal to x over 5. So again, I multiply both sides by 5. So you get x is equal to the cosine 53 times 5, which is 3.000. So it's round to the nearest tenth. So 3. 3, 4, 5. Pythagorean triple. Okay, number 22. All right. This is our hypotenuse. Oops. This is our hypotenuse. This is our opposite. This is our adjacent. Okay, so toa. All right, so we're going to find our opposite side first. So opposite and hypotenuse is sine. So we're going to use sine first. So sine 24 is equal to x over 14. Multiply both sides by 14, and you get x is equal to, so the sine of 24 times 14, x is equal to 5 point, round to the nearest tenth, 7. All right, so we just found our opposite side. Let me put that in there. Now we're going to use our cosine because that involves adjacent and hypotenuse. So I'm going to go cosine of 24 is equal to x divided by 14. Again, same process. Multiply both sides by 14. So you get x is equal to, so the cosine of 24 times 14, and you get 12.8. Okay? So that's 22. So let me put that in there. Whoops, wrong pop. It's 12.8. And I didn't think I'd put this, oh, crap, it's stuck here. This one was 3 up here. Okay, I think we got what, one more? Okay, so here is the trig section. All right, so this is going to involve our unit circle. So if we go back to the top, okay, our unit circle basically means it has a radius of 1. Okay, and as you can see, all right, all these points here, all right, are 1 unit away from the origin. Okay, either going on the x-axis to the right or the left, or the y-axis going up or down. Okay, so it has a radius of 1. All right, and so we're going to focus on this section first. Okay, so these values you want to try to memorize. All right, now these points right here along the unit, I think are relatively easy to find. Okay, you're just either going to the left or the right one, or up and down one. Okay, so that's where these values are coming from. Now, whoops. Okay, so when we're talking about points on the coordinate plane, all right, we always write them as x and y. Okay, but when we're talking about trig trig functions and the unit circle, our x's and y become cosine and sine values. Okay, so these values right here are just points on the coordinate graph. Okay, and these are just their coordinates right here. Okay, now if you notice, all right, let me draw these in here. If you notice, okay, these values get repeated throughout our unit circle. Okay, and what happens though is based on what quadrant you're in, okay, determines whether or not these things are positive or negative. Okay, so this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, and so there's a nice mnemonic that goes along with this. It's called all students talk constantly. Okay, and what this means is the all here stands for everything being positive. Your sine, your cosine, your tangent values, okay? All of these points over here are positive, which makes sense because you're in the first quadrant. All right? In the second quadrant, the only thing that's positive are your sine values. Now your sine values are your y values. And if you look over in this quadrant here, okay, our x's are all negative because we're on the left side of the y-axis, okay, but because we're above the x-axis, all our y values are positive. So that's what that mnemonic means in this spot, okay? Our sine values are positive. And I'm talking about these values right here, okay? Now, down here, for the t, what it stands for is our tangent values are positive. Okay, now tangent is really just our sine of theta over cosine of theta. Okay, that's one of our trigonometric ratios. And so if you notice, all right, both our sine and cosine and all these spots here are all negative. So what happens when you divide a negative by a negative? It becomes positive. So that's why all our tan values are positive in the third quadrant. And then if you look in the fourth quadrant, okay, we're on the positive side of the x, or we're going positively towards the right. You know, we're on the right side of our y-axis, so all our cosine values, or our x values, are positive, but our sine values are negative. So that's what this mnemonic stands for. All students talk constantly. And what it represents is which sine, cosine, or tangent value is going to be positive. Okay? Now, again, these are just points along our unit circle, or points in the coordinate, the coordinate plane here, but basically they just mark where they're located if we were to put this unit circle on a graph paper. Okay, so what this means here is at 30 degrees, okay, on our unit circle, let me draw my, okay, so at 30 degrees we get up to this point and we drop right down. And what do we have here? We have a right triangle. And so what we have here is our cosine, or our x value. This length right here is, darker color here, whoops, that's not going to work. It's going to be square root 3 over 2. And then our height here is just 1/2. So that's where that point is coming from. Remember, our x just measure how far right or left we are, and our y values measure how high up and down on the y-axis we are. Okay? And so that's where all these values are coming from. And if you notice, okay, 45 degrees is cool because it has just square root 2 and square root 2. So if you can remember 45 degrees, 90 degrees, well, 0 and 270, all of those, okay, then all you have to really try to memorize are these two. Now if you notice, okay, they're the same values, but they just get flip-flopped, okay? So 30 degrees, you look at this point right here, your x value, or your cosine value, is square root 3 over 2, and then your y value is 1/2. Then you go up to 60 degrees, and it just gets flip-flopped. So how I try to memorize these things is that when I think of 30 degrees always starts with that square root 3 over 2. So if you can remember that, you can basically build this entire unit circle. Because what happens here is after you go around, after you get up to 90, these values just start to repeat themselves, and then depending on what quadrant they're in, they just either become positive or negative. Okay, so I'm going to circle the ones, okay, that go with each other. Okay, so How about in green here? Okay, you notice we got square root 3 over 2 and 1 right there, and then if you look at 150, we got square root 3 over 2 and a 1/2, but our cosine, or our x value, is negative. If you go down here, okay, we see that same values for x and y, but now they're both negative. And if we look over here, okay, we see those same x and y values, but our y values are negative. Okay, and how they come up with these, all right, again, these are just points on that unit circle. All right, now, if you can memorize everything in this first quadrant, you can develop all the rest of these points along the unit circle. All right, and how you do that is we call these angles in the first quadrant here our reference angles. Our reference angles. Okay, and so what I mean by that is that these other ones, 150, 210, 330, okay, these values are based off of that 30-degree measure. Now, if you notice, all right, here's our horizontal axes, if you will. All right, these values, even though it goes counterclockwise and our degree measures get higher, all right, these reference angles are kind of built from this horizontal axis, if you will. So if you notice, 150 is 30 degrees up from our x-axis. All right, 210 is 30 degrees down from our x-axis. And the same thing over here. 30 degrees is 30 degrees up from that part, and 330 is 30 degrees down from that part. Okay, so they call these reference angles, or I'm sorry, they call 30 degrees, 45 degrees, and 60 degrees, and up to 90 degrees. I mean, well, actually 90 degrees isn't, but they're called reference angles because you can, if you memorize these, then you can come up with these other measures, or these other points along our unit circle. So if you look at 150, for example, all right, what you want to look at, all right, is which axes is it closer to? Okay, so here's our thing. We got 150 degrees here. All right, so which degree measure is it closer to? Is it closer to this line right here, to 180 degrees, or is it closer to this line over here, which is 360, when you go all the way around? All right, so the only time you're ever going to use that 360 axis is either when you're in this quadrant here or in this quadrant here, right? Otherwise, if you're over on the other side here, your closest horizontal axis is 180. All right, so let me draw that down there again. Okay, so here's 150. All right, so I'm like thinking to myself, okay, so pretend that we don't know 30 is our reference angle for 150. Well, in order to find that, okay, that's 180 degrees. This is 360 degrees. Which horizontal axis is it closer to? Is it closer to 180 or is it closer to 360? And it's definitely closer to 180. So you go 180 minus 150, you get 30 degrees. Okay, so then you can say, all right, well, what's the sine of 30 degrees? Well, the sine of 30 degrees, you go back up here, is 1/2. All right. Now, if they wanted the sine of 150, okay, well, you find your reference angle first, okay? So now, we look over here, what is our sine value? Well, it's a positive 1/2. Okay, so the sine of 150 is also 1/2. Now, if they said the cosine of 150, well, it's going to be square root 3 over 2, but because we're over in that second quadrant, now it's negative. All right, and so maybe, you know, they also, sometimes questions will do stuff like this. They'll say, okay, when is the sine of theta a positive 1/2? Okay, so we're looking for when 1/2 is a y value, all right? And as we go around here, we're looking for which one it's positive in. So down here, it's not positive. Down here, it's not positive. The only two quadrants it's positive in is the first one and the second one. So the sine of theta, when the sine of theta is equal to 1/2, that means we're getting 2 degree measures, which is 30 degrees and 150. Okay, so I'm kind of touching on a lot of stuff here. Hopefully this makes a little sense. Delete this stuff right here. But when I'm talking about finding reference angles here, guys, all I'm talking about is referring to angles from this first quadrant here. Okay? So that's what you're looking for. All right? Stuff from that first quadrant. So if I'm saying, what's the reference angle for, we'll say 240. Okay? Well, where are we closer? Are we closer to 180 or are we closer to 360? Well, obviously we're closer to 180, so 240 minus 180 is 60. So 240's reference angle is 60 degrees. And as you see, if you look at 240, right, these guys have the same exact x and y value, except, 240, both the x and y values are negative. So if they said, what is the sine value of 240? All right, maybe you don't remember what that is, so you go to your reference angle. All right, so, well, it's 60 degrees. What's the sine of 60 degrees? The sine of 60 degrees is square root 3 over 2. Okay, but because we are in the third quadrant, all right, our x and y values are both negative, so therefore this value is negative. And sometimes I also do stuff like this. When is the sine of theta negative square root 3 over 2? Okay, so then we go around, we look at our y value when it's negative square root 3 over 2, so I see it here, or square root 3 over 2 is there, square root 3 over 2 is there, and square root 3 over 2 is there. All right, which one of these are negative? Well, it's going to be, theta is going to be equal to 240 degrees. That's when we're getting a negative square root 3 over 2. And then also, we are getting a negative square root 3 over 2 for a sine value at 300 degrees. Okay, so that's where these things are coming from. That's what I kind of mean by reference angles. It's just a way to just, instead of trying to memorize all of the circle here, all you have to try to memorize is the stuff from the first quadrant. And then you can build the rest of this unit circle based off of what you know from the first, or based off the information from the first quadrant. Okay? So, that being said, let's go down to the bottom here and finish out these problems here. Okay? So it says, now the idea here is that you don't rely on the unit circle to solve these. Like, obviously we can use our unit circle, all right, and just go up and just copy what our sine value is here. But there's you want to make sure that you're trying these problems, all right? So let's say the sine of theta, all right? So right here our sine, so wants to know what's theta. Well, theta is 225. Now, if we scroll up, okay, we go to 225. So here's 225. What's our sine value? Right, well, it's our y value, so it's negative square root 2 over 2. Okay? So that is, if you're using the unit circle, you just go up there and check it out. Now, let's do it the grunt way. Okay? Brute force here. All right, so we go back down and say, okay, sine of 225. Well, here's our horizontal axes. All right? And we want to know, where is it closer to? 180 or 360? Well, clearly it's closer to 180, so then you go 225 minus 180. You want to make sure you subtract the larger number from, or the smaller number from the larger number, and you get 45. Okay, so 45 degrees is the reference angle for 225. Okay, now, so what is the sine of 45 degrees? Well, the sine of 45 degrees is square root 2 over 2. Now, all students talk constantly. Okay, we're in the third quadrant, which means only the tan values, our tangent values, are positive. So that means this is negative. And that is how you can come up with these without having to just go directly to the unit circle. Okay, it's important you guys try to memorize these. Okay? All right, so let's take a look at number 4. Okay, so cosine of 150 degrees. Again, if we scroll up, go to 150 degrees, what's our cosine value? Negative square root 3 over 2. Okay. Now I'm not gonna just put that down there. We're gonna use our reference angle and make sure that that is what we should be getting. Okay, so again, which horizontal axes are we closer to? Are we closer to 180 degrees or 360 degrees? Well, obviously we're closer to 180, so you're gonna go cosine. Oh, I'm sorry, 180 minus 150. So the reference angle for the cosine of 150 degrees is 30 degrees. Okay, so the cosine of 30 degrees, if you remember, square root 3 over 2. Let's think about what quadrant we're in here. So all students talk constantly. So the only thing that's positive in the second quadrant is our sine values, which makes our cosine negative. All right, and which is exactly what we have there. Okay, so there's that one. Let's go back down. Whoop, too far. Okay, so the tangent of 240. Now, if you go back up here, you'll see that, oh man, they don't have any tangent values. Okay, we can't just look at our chart now. We actually have to do a little bit of memorizing and a little bit of math. So first, let's look at our reference angle. So here's our horizontal axes. Okay, which quadrant is it, or which angle, or reverse? Which horizontal axis is it closer to, 180 degrees or 360? Obviously, it's closer to 180. All right, so 240 minus 180, and you get 60. Okay. Now, the next part is, all right, so we're looking for the tangent of 60 degrees. Well, we don't have that up at the chart, but we do know that tangent is equal to the sine of 60 degrees divided by the cosine of 60 degrees. Remember, tan of theta is equal to sine of theta over the cosine of theta. Okay, so the sine of 60 degrees, if you recall, is 1/2. Oh, I'm sorry, nope. Heyo. Sine of 60 degrees is square root 3 over 2. And the cosine of 60 degrees is 1/2. And you can go back up there and look if you don't believe me. Go to the cosine of 60 degrees. Cosine is 1/2. Sine is square root 3 over 2. Okay, so when you divide fractions, okay, you got to keep the first one, flip the second one, whoop, change to multiplication. What cancels are 2's, and you're left with square root 3. All right, so we're making progress here. So the tangent of, what is it, 240 is equal to square root 3. Now, which quadrant are we in? All students talk constantly. What's positive here are tan values, and so we're good. And that's number 6. Number 8. Okay, tangent of 150. All right, so our reference angle, if you recall, is 30 degrees. All right, so the tangent 30 degrees is equal to the sine of 30 divided by the cosine of 30. Okay, well, sine of 30 is equal to 1/2. And the cosine of 30 is square root 3 over 2. Again, getting that right from the unit circle, so you got to try to remember these things. Okay, our sine is 1/2, our cosine is square root 3 over 2. All right, we're talking x and y values here again. So we go back down. We're going to have to keep, flip, change the multiplication. 2's cancel. And you're left with 1 over square root 3 can't have a radical in the bottom, so what you have to do is you just multiply the top and the bottom by square root 3 over 3, which is a math trick. I'm just multiplying by 1. But what happens here is those things cancel. Anytime you multiply a radical times a radical with the same number inside, the radicals go away and you're left with square root 3 over 3. Okay, so we're not done here yet though, so the tan 150 is equal to square root 3 over 3. But what quadrant are we in? We're in the second quadrant. So all students talk constantly. What's positive in the second quadrant? Only our sign values, which makes that negative. Okay. Still making room here. Okay, so the tangent of 225. Okay. Well, what's nice about 225 is its reference angle, if you recall, is 45 degrees. All right, so we're looking at the tangent 45 degrees is equal to the sine of 45 degrees divided by the cosine of 45 degrees. Well, the sine of 45 degrees is just square root 2 over 2, and the cosine of 45 degrees is another just square root 2 over 2. So what happens is, even though they're both fractions, there's no need to keep flip changing it because I'm just dividing the same thing. I'm just dividing it by itself. So we end up getting an answer of 1. So the tangent of 225 degrees is equal to 1. And then now we've got to look at what quadrant we're in. All students talk constantly. So the only thing that's positive in the third quadrant is our tan values. And so we're good. Okay, now these ones are actually the same problem, okay? I don't know why they have that there. Okay, so the cosine, oh, I see. All right. No, yeah, cosine of theta. So, right, am I doing something wrong here? Why do they have that question twice? I have no idea. Must be a typo. Okay. So, now remember, these points along our unit circle, okay, this is 1 comma 0, this is 0 comma 1, this is negative 1 comma 0, and this is 0 comma negative 1. Okay, so it says what is the cosine of 270 degrees? So if you look at this point here, what is our x value? Right, because it's cosine and sine. So our cosine, or our x value, is just 0. So the cosine of 270 degrees is 0. Okay? And that's it. So if you look at the sine of 0, well, here's our unit circle. Boy, that was a bad one. Okay, let me retry that. Okay, good enough. All right. So the sine of 0 degrees. So right now we're at this point right here. We haven't gone around our unit circle at all. So what's our sine value? Well, this point is 1 comma 0. So the sine of 0 is just our y value, which is just 0. So sine of 0 is 0. Okay? And hopefully that wasn't too bad for you guys, but really all I want you guys to take from this unit is just a little familiarize yourself a little bit with this unit circle, and just being able to find the missing sides of triangles, right triangles, if you will.